welcome to the beginning of the expressions and equations unit. We're going to start off with some important terms that we're going to be referring to throughout the packet. It's important to start here so we have the same vernacular, so the same terms that we can be talking about throughout. So let's go ahead and start with page 1. An unknown quantity or expression whose value can change. This is a variable. Parts of an expression that are separated by pluses or minuses. So we're going to talk about this and see some examples, but this is a term. Part of a math sentence whose value is always the same, represented by a numeral, that would be a constant. A numerical or constant quantity placed before and multiplying the variable in an algebraic expression, that is a coefficient. When I was in school, my math teacher gave us spelling tests, and coefficient was always on that list. Try to do your best. A combination of variables, numbers, and or operations that represents a mathematical relationship, but no statement of equality or inequality. Well, that might be giving it away here. That is an expression. And expressions does not have an equal sign. Conversely, maybe you see where we're going here, a mathematical statement that two or more expressions are equal, well, that is an equation. And an equation must have an equal sign. It's going to be difficult for me. All right. There we go. Okay, an algebraic relation showing that a quantity is greater than or less than a quantity is an inequality. And it would have one of these four symbols. We'll talk more about those, huh? A greater than, a less than, a greater than or equal to, or a less than or equal to. Terms that have the same variable raised to the same exponent, which can be combined, are trying to give me grief here. Oh my God. Like terms. There we go. A designation for a group of terms often bounded by parentheses. We would call this a quantity. The text box field does not want to cooperate. Okay. Maybe we'll just switch over to the pen here. All right, so a group or expression with one term is called a monomial. Ugh. A group or expression with two terms is called a binomial. A group or expression with three terms, can you guess the prefix? That's a trinomial. A group or expression with many terms is a polynomial. Maybe take this from your social studies class. You talk about polytheistic religions, believe in many gods, poly meaning many. Okay, tri meaning three, bi meaning two, mono meaning one. All right, I added this one in here. I know it's not on your worksheet, but add another line in here. The highest exponent in an expression or equation, that's what we call the degree. So we're going to look at how we can kind of identify all of these in some examples here on the next page. Okay, so on this page it says classify each expression with the most specific term, monomial, binomial, trinomial, or polynomial. We'll start with that first, then I'm going to change the directions a bit. Okay, so we need to figure out how many terms there are. So we want to look at terms, and we defined terms above as pieces that are separated by addition or subtraction. So I'm going to go ahead and circle a term. So this is a term, and then there's an addition or subtraction. So this is the next term. And I like to continue to circle the sign in front so I remember what the sign of that term is. We're going to talk about that more to come. Then this is a term here. And then this. So this one has four terms. So from up above, we have a name for 1 term, 2 terms, 3 terms, but if it's basically any more than 3, we're going to refer to them all as polynomials. I'm going to write this over here, giving myself some space over there. All right, because I'm actually going to change the directions. In addition to determining if this is a monomial, binomial, trinomial, or polynomial, we're also going to determine the degree. So the degree, as it says, is the highest exponent in an expression or equation. So if we look, what's the highest degree? So this is a degree 5. So we're going to say this is a degree 5 polynomial. Usually we like to put the degree first and then the number of terms second. Okay, great. So we labeled it by a degree and by the number of terms. Okay, in this next one, let's go ahead and circle the terms. There's 1 term, 2 terms. Okay, so we know it's going to be a binomial for 2 terms. Now, what's the highest exponent? I don't see any exponents. But if we look at the n there, it doesn't have an exponent, but when you don't see an exponent on a variable, you can assume that that would be equivalent to the first power. We don't write first powers, but that's what that's saying. It's an invisible 1. So this is a first power. We could say a degree 1, but the first 3 degrees, at least, have some very special names. And so we're going to talk about those, and I'm going to make a little chart over here to describe them. Okay, so if the highest exponent is 1, we're going to call that, actually I'm going to come back to 1. I'm going to leave a space there at the top. If the highest exponent is 1, we're going to say that is linear. Okay, so this is this case. The highest exponent is 1, so this is a linear, that's the special term for a degree 1, linear binomial. If the highest degree is 2, that is a quadratic. And why you're seeing quadratic, you're thinking 4, but the exponent is 2. Well, if you think about something like x squared, what you really have here is squared. And this is highly related to an actual square. So at the point in time when they came up with these names, the quad here was referring to that this is talking about a square that does have 4 sides. So they didn't make it completely to confuse you, even though it can definitely accomplish that. All right, if it's a degree 3, that is a cubic. There are names for 4 and 5 and probably even beyond that, but really these are the ones we're going to learn up to 3. Beyond this, we're just going to go ahead and list the degree number like we did here. So we'd say like a degree 4 or a degree 5. Now, we can't actually have a degree 0. A degree 0 is no variable. There's no variable present in the expression or equation anywhere. And if there's no variable, then there has to be at least a number, and so that is going to be a constant. So think if no variables there, it's a constant. There's nothing to change. So degree 0 is constant. So this little chart, definitely copy this down, definitely memorize this because you're going to be tested on this. Okay, for number 3, I have a minus sign out here, but there's no other term it's separating from. So there's really just one big term here. So this is a monomial. Its exponent is a 4, so that's beyond our chart again. So we're just going to say a degree 4 monomial. Great. All right, number 4 has 1, 2 terms. So it is a binomial. I'm trying to read underneath what I wrote up there. I can't see it. What did I write there? Okay, it was a 2. All right, so this is, go to our chart, degree 2, that's a quadratic. A quadratic binomial. Doesn't that sound fancy, right? Impress your parents by saying, oh, I'm talking about quadratic binomials in class today. No big deal. All right, so the next one, okay, 1 term, 2 terms. So it is a binomial again. Highest exponent we see is a 2. Okay, once again, we have a quadratic binomial. Awesome. Okay, now 1 term, 2 term, 3 terms. Okay, 3 terms, that's a trinomial. And this is where definitely students start to eventually, cross these up. Okay, 3 terms. Wait, was that cubic? Nope. 3 terms means trinomial. And when we look at the degree there, kind of covered it up. It was a 6 there. We don't have a 6 on our chart for degree, so we just go ahead and say degree 6. So a degree 6 trinomial. Number 7 has but one term, so it is a monomial. The exponent is 5. That's off our chart, so a degree 5 monomial. Great. Number 8, one term. Okay, that's a monomial again. What is the exponent of r? There's no exponent written. Remember, no exponent written. It's an invisible 1 up there. So this is a linear monomial. Great. Okay. So we certainly are, can practice more of classifying in the next page, but let's go ahead and look a little bit more at some of those terms and see if we can see how they are useful in describing expressions. Okay. So in number 9, we have the expression 2k plus 15 minus m minus 3 plus n minus 7p. Okay, so let's talk about what are terms here. There's a lot of them. 2k is a term. Then we have an addition or subtraction, so this is a term. I'm circling the sign in front every time. Negative m is a term. Negative 3 is a term. Positive n is a term. Minus 7p is a term. Whoa. Okay, so I'm going to list those out. Here are my terms. 2k. I'm going to just separate them with commas. Positive 15. I don't need to write the positive. But I do have a negative m as a term. That is a negative m. It's not just m, it's negative m. We have a negative 3 as a term. We have n and negative 7p. Those are the terms. 1, 2, 3, 4, 5, 6 terms in this one. Okay, let's go through and find variables. Variables are basically your letters. So we've got k, we've got m. Here we can drop the negative. We're just looking for the letters of the variables. We've got an n, and we've got a p. So we've got 4 variables. Okay, now here comes a place where we might be talking about a new thing for you, something you haven't seen before. It's one of our terms. It's a coefficient. And we said it's the number multiplied by a variable. So here I see k. This 2 in front, there's nothing written between the 2 and the k. That means multiplication. So 2 is the coefficient of k in this term. So 2 is one of the coefficients in this problem. Okay, 15 is a number. It doesn't have a variable there, so no coefficient. It's a number. We're going to talk about that in a second. Now here we have a variable. All variables have coefficients. Now, we just see a minus sign. What would be the number here, though? So again, 1s like to hide on you. This is really minus 1 or negative 1 times n. So if we took the value of m and multiplied by negative 1, that would be the same as taking basically the opposite of m. So m's coefficient is negative 1. N's coefficient has a plus sign in front. So really here, it's a positive 1. That's its coefficient. And then lastly, p, that's a negative 7 in front. So all variables have coefficients, even if they're invisible. Okay, for our constants, now we're looking for places that are terms that don't have variables. So this would be like our 15. And 15 is positive. Great. Okay, the next term has an m. But then we have a minus 3, or a negative 3. So those are our 2 constants. They're not multiplied by variables. They're not connected to variables in that way. They're not in the same term as a variable. Okay, so we've broken down that in great detail. Let's go ahead and do number 10 the same way. Listing our terms. Okay, I think it does help to take a second and circle the terms with their sign in front. Okay, so we have 6 terms. I'm going to go ahead and list them out. Negative 8 is a term. Negative 4c is a term. 7. I've written so big I can't see what I've got under there. Make sure. Okay, they were both c's. Okay. All right, we've got negative c as a term, negative 12c, and negative 2. Okay, our variables are just c. We've got a bunch of c's. I'm not going to write it over and over again. It's really the same variable every time, so just c. We've got coefficients, though. The first time we see c, its coefficient is negative 4, right here. The second time, I see a minus sign, but what number is hiding there, right? It's a -1. And then, the last time, -12. All right, great. So now look for the terms where there's no variable at all. The first one here gives us our first constant, -8. Okay, here we have a variable in this term, but then the next term is just +7. Variable in the next term, variable in the next term, but the last term is -2. Okay, so we've really picked those two expressions apart into terms, variables, coefficients, and constants. Here's just kind of another way of looking at things. Let's go ahead and label the parts of this. In this one, 8y, the 8 represents what? It is a coefficient. It's being multiplied by the variable. So it's a coefficient. Y, of course, it's a letter, is a variable. -7, it's a term, no variable present, so it is a constant. Great. How many terms are present in this expression? So there's one. Then we have an addition or subtraction to separate this one, and then another. So we have 3 terms, and they are 8y, -7, and 2y. In number 12, m here is a variable. +4 here is a constant because there is no variable in that term. And -7 here is a coefficient. Great. Okay, so how many terms are present in this expression? We've got 1, 2, 3, 4, and 5. 5 terms. So they are m, 4, 2, -7m, and 6. Okay, so another way to pull apart all the details of our expressions. In the next 2 pages, you're going to have to repeat these same skills over and over again to practice and make sure you really know some of these new definitions that we're talking about this time.